Okay, now let us assume the case of the quadratic interpolation in case of spline. So spline quadratic interpolation. So let's consider the data points like this. So okay, t equal to 0, 10 and 20. We are considering only 3 data points, but normally it will be having very large number of points. But for understanding, we will consider only 3 data points here that are known. So first one is time and the second one is velocity. So if you consider these splines, let's assume that your spline is in quadratic form, and we can have v of t can be written like this: a1 t square plus b1 t plus c1, and in between this range, that is from 0 to 10, and you will be having a2 t square plus b2 t plus c2, and which will be in between this range 10 and 20. So we have different coefficients corresponding to two different spline. This is your first spline and this is your second spline. Okay, so then we can write, we can take the first value, that is the first y0, then first x0 point is 0, first x0 is means that this value, first x value is 0. So then your our equation becomes like this: a1 0 square plus b1 0 plus c1 equal to 0, because our t value is equal to 0. The x-axis is in time, so t equal to 0, that is first case, and that is for this point. And when you consider the second point for the same spline, that is your s1, for the same spline we will be having this equation, that is a1 into 10 square plus b1 into 10 plus c1 equal to 100. And similarly we can have this case here. The point will be sharing with the first spline, but we will be having a different coefficient here because we have a2, b2 and c2, but the y value will be same. Okay, so we will be having for the second spline s2, for s2 we will be having this equation: a2 into 10 square plus b2 into 10 plus c2, which will be equal to 100, that is y value. And we also have the last point, which is a2 into 20 square plus b2 into 20 plus c2 equal to 240. So these are the two equations corresponding to these data points. But we are having two splines here, and we'll be having for example in this case we have 6 number of unknowns, that is a1 b1 c1 and a2 b2 c2. So basically we have two splines, we have 6 number of unknowns that we already know. If you are having n number of splines, then you will be having 3n number of unknowns. In this case we are having n equal to 2, that is 2 number of splines, then which means that 3 into 2 will become 6 unknowns. Okay, 6 unknowns. So that is the basic idea. So we have 6 unknowns, but we have 4 equations here. So then we have to consider the point, that is this point, okay, where we will be having same differential for both the splines. So we take the differentiation at t equal to t0. Actually I think it is t equal to t1, right? So this should be t equal to t1. At t equal to t1 we will be having same kind of slope. So d by dt of a1 t square plus b1 t plus c1 should be equal to d by dt of a2 t square plus b2 t plus c2. And from that we will be getting this equation, that is at t equal to t1, that is t equal to 10. Okay, so then we'll be having this 20a1 plus b1 minus b1 minus 20a2 plus b2. So this is I can write it again. This is 20 a1 plus b1 minus 20 a2 it is 20a2. 20a2 it should be minus b2. Okay, minus b2 equal to 0. So we'll be having this equation, and so this is the next equation. So we'll have 5 equation now. Okay, now again we will consider the boundary condition, and I have considered both the boundary condition. We can consider it differently. So first I have considered the last point as my boundary my boundary condition at the last point. We have applied this boundary condition, and that is d square xn by dt square will be equal to 0. That is d square Sn by dt square equal to 0. That is for last point at x equal to xn. At x equal to xn. Okay, so that is the last point. So that we have to consider. So this is equal to 0 at, that is by boundary condition. So then we will get b2 into 20, this equation b2 into 20 plus c2 equal to 240. If you are applying this boundary condition, then we will be having your a2 equal to 0. Directly your a2 becomes 0, and we will be having this this part only in your last case. Okay, that is b2 into 20 plus c2 equal to 240. So that is the 6th equation. So now we will have 6 equation and 6 unknowns that we can solve, and actually I have solved. So you have to solve this equation by, you can solve by hand, or you can use the matrix algebra. So basically it is coming like a1 equal to 0.4 and b1 equal to 6 and c1 equal to 0 and a2 equal to 0, b2 equal to 0.14, and I don't know whether it is 0.14. I think it's I think it is 114. So it is, you can check that 14, and c2 equal to some 40. So this is when I consider the last point as a by boundary condition, that is d square Sn by dt square equal to 0 at x equal to xn. You can also consider d square Sn by d square S0 or S1 by dt square equal to 0. That is first spline, second differential becomes 0 at x equal to x0. That is initial data point. And if you consider that case, then we will be having the your first spline will become linear in that case, and you are having a different coefficients, a1 equal to 0, b1 equal to 10, and c1 equal to 0, and a2 equal to 0.46, and b2 equal to minus 0.0531, and c2, we have c2 equal to 40. So these are the coefficients that I have got by using by mathematical calculations by hand, but you can also use this by using your lean algebra in your matrix method. Okay, where what you had to do, that I will discuss in next module. Okay, so this is the basic idea. You had to find out this coefficient first. So I hope you understood this method. How we can do this is just for quadratic case. You can also use for cubic case, but it will be having one more power to the x, and you have to solve those equations and to find out what is the exact procedure. Okay, so we will discuss the method by using Python next